Hi, Cameron. How are you? Hi, everybody. How are you doing? Okay, so we'll start in a few minutes. Do you have any question before we start? You okay? Okay, we'll start in a minute or so. Okay, hang tight. Just trying to wait for everybody to get on. Okay, so in this week, we're going to talk about chapter 11, which is sequence and series. But before we start, I want to share with you an opportunity you can get some extra money. I posted in the announcement yesterday, there's a thing called Mobile Learns, and this is sponsored by City of Moreno Valley. So if you check this out, you can get $250 per month and up to $2,000 a year, which is 2 semesters. And to qualify, you have to fulfill the criteria listed there. So if you have the requirement met, you can click on the link and then click apply, and you can submit that, and that will go to the dean. She will evaluate that. With that, I think you only have to answer some questionnaires and you can get some extra money. So hopefully you can take advantage of this. Okay. For this week, we are covering Unit 8. And I want to point out that we do have a homework assignment this week. That's going to cover the review for our next quiz, which is next week. And the homework assignment is due on the 20th, which is 7 days from now. So make sure that you check out the homework assignment and complete it. Today we are going over sequence sums and series. And if you haven't downloaded the notes and the assignments, make sure you do so. Okay, so I'm going to go over that next. And also they have released a survey for my evaluation, and that should be sent to your email. If you have some time this week, make sure you complete the survey. Your feedback is important to me. We can discuss my evaluation during the meeting in November. So I do that with the dean. And Mr. McQueen will be popping in the class, could be live or he could be watching the video. So he's the one that's going to evaluate the class. And so if you get an email from the district or from one of the faculty, make sure that you complete the evaluation, and I appreciate that. Okay. All right. So this week we are going to touch on sequence sums and series. And to start, we want to define what a sequence would be and what it would look like. Okay. So a sequence, basically, it's a collection of objects. And in the sequence, we allow repetition. So you can have repeating of numbers. So let's say if we're using whole number like integers, you might see the number being repeated inside the sequence. So for example, I can have 111, 222, 333, etc. So because it's enumerated in the programming side, we can think about how we can iterate through that, using whether you're using a container like array or vector, and we will touch on that on Thursday. Now, in a sequence, each item, each member, we can consider that as elements or terms. And we can have infinite number of elements, or we can have finite number of elements. So in the case where we have finite number of elements or terms, we would have something that called the length of the sequence, the total number inside that sequence. So like the set, it can contain elements and term, but unlike the set, you can have repetition of element values or term values, and order does matters. So the first one is in the first index position. That's different than the second one in the second index position. Now, what we want to do in a sequence is really looking at a pattern that occurs in a sequence. So a sequence can be a type of function, and that could have consecutive set of integers. It could have different types. So in the domain of the function, you would have different values right here, like 1, 2, 3, 4. That could represent years. Or you can have different set of values, but in most cases we would use integers to represent our sequence in this class. So you can also have a subset of integers that would represent a sequence, and we would see that in our exercise. Okay, and the way we write this is we want to show that a of n is the term. So for example, the first term, that would be a of 0, and in some textbook or in some course that would be represented as a of 1. Now if we consider n starts at 1, not like how we would program it start at index 0, then we can substitute in that 1 to be able to calculate for t of n or f of n. So in the first example, it shows you here, we start with the first term is 1 over 1, which is 1. The second term is 1 over 2. The third term is 1 over 3. The fourth term is 1/4. The fifth term is 1/5. The next term is 1/6, and so forth. So we can say that if n is equal to 1, then it's 1 over 1 for the first term. And n is 2, then it's 1 over 2 for the second term. N is 3, it's 1 over 3 for the third term. So with this, we can start recognizing the pattern that when we increase the n value, the denominator actually is representing the n value. Okay? So therefore, after the 6th term, we know that we would reach the 7th term. That's going to give us 1/7 because n is shown in the denominator. So what you would have is t of n is 1 over n. Okay, this formula or this function would represent the sequence. So now what we can say is that when we reach 100th term, we would have 1 over 100. If we go to 1,000 term, we would have 1 over 1,000 for this domain. Okay, do you have any question? Okay, so let's take a look at the next example. So we have a given sequence. They are even integers. We have 2, 4, 6, 8, 10, 12, etc. And this can go infinitely. So we would start with the first term, which is n is 1. So we can say if n is 1, to find the 2, we would have to take n times 2, which gives us 2. If n is 2, then to find the next term as the second term, we would have to take 2 multiplied by n, which is 4. And then we would do the same thing for the next. If n is 3, we would take 2 times 3, which gives us 6. That would be our third term. And so we would continue this. So if we can say that n is 22, if we want to find out the 22nd term, we simply take the 2, multiply it by 22, which gives us 44. So we can say that 44 is the value at the 22nd term. So the next term after the 6th term, that will be the 7, because we simply take 2 times 7. that gives us 14. Okay, when n is 7, then you can take 2 times 7, which gives you 14. Okay, so these are very easy. And then let's take a look at a couple more before we start. So now we're looking at a different sequence. This also contains even values, but it contains a different pattern. What we have is, as we move to the right, as we increase the n value, we would see that it exponentially increasing. Okay, so we would start with if n is 1, so we start with 1. Then to find 2, we can simply raise 2 to the first power, we can have a 2. Okay, if n is 2, then we can say 2 to the second power gives us 4. If n is 3, 2 to the third power gives us 8. So if we need to determine the 7th term, which is after the 6, what is the value there? So we simply take 2 to the power of n, or this could be 2, and we want to raise that to the power of 7, which gives us 128. Okay, so basically what you need to first determine is to be able to come up with the function that would represent that sequence, and then apply that function to determine the nth value. Okay, and then also the fourth example. So what you see there is different type of sequence, and when you see what the sequence is that we want to be able to derive some kind of function from each of the sequence. And when you program this, you can apply this as part of your algorithm. So that way we can be able to pinpoint, right, the value at a certain index position, or we can use it to sum, find average, or other things. But we first need to determine the function. So in the fourth example, we're given 7, 8, 9, 10, 11, 12. And you notice that it starts at 7, so your first term starts at 7. So we can say if n is 1, we would take 1 plus 6 gives us 7. So you want to apply the n somehow, right? That's the whole point in creating or writing out that function, is to apply the nth value. And then in the next term, if n is 2, then we would take 2 plus 6 gives us 8. If n is 3, we take 3 plus 6 gives us 9. So after the 6th term, we know that the next one is increasing by 1. So we would know that it's 13. But applying this formula, we would see that T of n is n plus 6. Or in our case, when we find the 7th term, it will be 7 plus 6, which gives us 13. Okay? So we saw at the beginning, we saw using n as the denominator, using n as exponent on the next one. And when you see it increasing like this, that's a arithmetic progression. Okay, and then we also look at geometric, looking at these sequences, and we'll come back to that, and quadratic. All right, let's look at the fifth example. So in the first term, you're given 1/2, so 1/2. In the next term, you have 1. The following term, you have 2. The following term, you have 4, 8, and 16. So we can say at the first term, if n is 1, you can have 2 raised to the power of n minus 2. So the exponent is going to be n minus 2. So 1 minus 2, which gives you 2 to the negative 1 power, which is 1/2. If n is 2, then we can take 2, raise that to the 2 minus 2, which is 0, which gives you 1. If n is 3, then we would have 2 to the 3 minus 2 power, which gives you 2 to the first, or 2. So we started to see the pattern here. You notice the n value here. Okay. Then we can say that our function is t of n is 2 raised to the n minus 2. So to find the 7th term after the 6th term, we simply apply the formula or the function where we can say 2 raise it to the power of 7 minus 2, or 2/5, which gives you 32. Okay, any question? Okay, so let's go to the assignment now that we looked at a few examples. Then we can try to solve this. So you're giving the sequence, okay? You have 1/2, 1/6, 1/8, 1/10, etc. And it continues, okay? It asks you what is the next term after 1/10 in the sequence. Write the formula or the function that represents the above sequence. So let's start with n is 1. Then we can see that it's 1 divided by 1. If n is 2, then we can have 1 divided by 2. So in the first two, it's started to have some kind of pattern, but it stops there. Okay, and sometimes you do see that. You see that with some of the numbers, right? Like with Fibonacci is a little bit an exception that you have to have a base case, and with that base case you can build upon it. Now in some cases the sequence doesn't start until the later terms, and that's okay. Then we have to give the value for the initial. Okay, so let's look at it. When n is 3, then you would have 1/2 times n, which is 1/6. If n is 4, then we have 1 divided by 2 times n, 2 times 4, which is 8. And it is also the same for the next case. When you have it as 5, f of n is 1 divided by 2 times 5. Let me put that in parentheses so you can see. Equal 1/10. So what I concluded from this, and this is a tricky one, is that in this sequence, the first 2 term is 1/n. Okay? Then the actual pattern begins at the 3rd term. So when you write this out mathematically, you would say when n is 1 and n is 2, it's 1/n. And anything after that, when n is greater and equal to 3, f of n is equal to 1 divided by 2 times n. Okay, So there are multiple conditions. There are two conditions in this sequence. In the first part, that the first two numbers, sorry, my dog. Its function is 1 divided by n. Then from the third term going forward, we have the function as 1 divided by 2 times n. And you can see that's represented there. Okay. And if you wanted to write it like this, you can do insert equation and then you can select. So this is a large curly brace, which we can apply, we can specify our term value and the function for each one. Any question? Like in the definition earlier, it says that yes, it would have some kind of also subset that represents a different function, and then after that you would have a sequence going from the third and forward. Any question with number 1? So when we take this into the programming aspect, right? You saw some of this when you were working on your program last time. Okay? What we can do is we can implement the first piece for these two. We can say if n is 1, right, it would give you this. If n is 2, it would give you this. And then we can loop it after the third. So we would start it with the third and then continue to loop to the end. Okay, question? So to complete the answer for that question, we need to calculate the sixth term. So we simply take 1 divided by 2 times n, or that would give you 112. So 112 is the sixth term. So unlike the set, remember the set, you have to have unique values. In the sequence, you can have the repeating values. Okay, so let's take a look at number 2 if you have no question for number 1. So what we see here is we need to first start identifying the pattern. And the way we look at this is that when you're looking at the sequence number 2, 5, 10, 15, 20, and it will continue. So we would see an increment of 5, right? Like 5 plus 5 give you 10, plus 5 give you 15, plus 5 give you 20. So there is an arithmetic progression. The distance between one value to the next is a plus 5, is added 5. Okay, but we need to apply that into a function. So we have to really determine what is our common ratio at this point. Okay, so the question asks us, what is the next term in S? Write the function that represents the sequence. So just like the first one, what we want to do is we want to start with the first term. If n is 1, you have f of n is equal to 5 times 1, which gives you 5. Then we move to the next term. If n is 2, f of n is 5 times 2, which gives you 10. If n is 3, f of n is 5 times 3 gives you 15. So for the fifth term, after the 20 here, we simply take 5 times n, and our n value for the fifth term is 5. So 5 times 5 gives us 25. Any question? So for quiz and exam, right, you will be given a sequence and you need to come up with a function that represents that sequence. Or in some question, it will ask you to determine like the 20th value in that sequence. So yes, you have to come up with the function that represents that sequence and then use the n value to calculate the value at that position, 20th or given position. Any question on number 2? Okay, so let's do, so before we go into this, so there are additional example here. You can take a look at some example, right, on how that would apply to the n value. So example 6 and 7, it shows you, and in 7 you see that it's repeating 1, 1, 1, 1, 1, and it will continue forever as that. So how do we make that into a function? We can say it's n divided by n, which gives you 1 every single time. Okay, that is a unique one. And in example 8, that's kind of like our first exercise. So you have the first one as 1, and then you have the next one as the same, 1, 1. Okay? And so you would have, if n is 1, then t of n is 1. So it would return 1 there. And then if n is 2, then t of n is 2. And then after that, what you see is that it's going to take the previous value and it's going to add it. This is Fibonacci. So we seeded at 1 here. So you have 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. So this is a perfect one for recursion. And we will come back to Fibonacci and do a lab on Fibonacci. Okay. So you do see a pattern starting at the second term and forward. So we can say that your t of n is going to be n minus 1 plus n minus 2. Okay, and the way we write it would be like this. Okay, so let's look at 9. I think you can apply 9 to your assignment. So we have 1/2, negative 2/3, 3/4, negative 4/5, 5/6, negative 6/7. So when you're looking at a sequence like this, we know that our common ratio would have some kind of negative value. And when it deals with fraction, your exponent is likely going to be in the negative, so it needs to subtract there. Okay? So we would see that your n value is here, but there's a pattern on the bottom here, right? So since it's alternating sign like this, like I said, you would have to multiply it by some kind of negative, and when you raise that to the exponent, what happens is it's gonna, every other number is gonna give you a negative. Okay, so in this one, what you have is you have -1 times n minus 1. So just like what we did before, you can start writing out. If n is 1, then you try to solve for the first term. And as you write through, what you have is you're going to have f of n or t of n. And here I concluded that the t of n is -1 times n minus 1. Or raise it to n minus 1 times n divided by n plus 1. I'm just double checking in my head. I'm sorry for the pause. Okay? All right, so let's take a look at our assignment. So you have sequence 5, 7, 4, 14, 3, 21, 2, 28, and it continues. It asks you to determine the next term after 228. Write the T of n formula that represents the sequence. So we would start with, if n is 1, we're trying to solve and get it to be 5, 7. So what we have is we would have 6 minus 1, right? We have to apply the n here. So you take 6 minus 1, that gives you a 5 for the numerator. For the denominator, we can take the n and we would multiply it by 7, which gives us 7, because you do see a pattern on the bottom here. 7, 14, 21, 28. So it's 7 times n. Okay? So when we solve this, we can say that that would be 5, 7. And yes, we would come to a formula shortly. So I want you to look at the sequence first, and then we would apply a formula for progression. If n is 2, t of n is 6 minus 2 divided by 7 times 2, which gives you 414. And that's not reduced, right? I left it that way so it's easy for you to see the pattern. So we can conclude that t of n is 6 minus n divided by 7 times n. And when we plug n in for the fifth value, then we would have 1 over 35. So that would be 6 minus 5 divided by 7 times 5, which is 1 over 35. Okay, any question? So as we look at this, you should ask me, is there a better way to do this? You know, yes, they already created a formula that we can apply, right? Instead of trying to guess and trying to. So the first few exercises shows you how you can start recognizing the pattern and see the progression in n and how the n is applied. Okay. So what you see in some of these example and the exercises that we would have what's called the arithmetic sequence or progression, where each of the term equals to the preceding term plus a constant, like what you saw before, 5, 10, 15, 20. So you would take 5, you plus a 5, which gives you the next term, 10. Then you take a 10 plus a constant, which is 5, gives you 15. 15 plus a 5 gives you 20. So in that case, we would have an arithmetic sequence. So in the arithmetic sequence, you would be able to see the difference between the consecutive terms, and it's always the same. The distance between one term and the next term is always the same. Yes, it can go the other way, like negative. So I can subtract 5. Let's say I start with 20. I subtract 5, I get 15 on the next value. Subtract 5, I get 10, and so forth. So you have to look at the difference, and that will be a constant value. Okay? So in the arithmetic progression, the difference between the consecutive term is always the same. Okay? And the way that we use this in the formula here is that the D represents that distance, that difference. Okay? Okay. So the formula that we can use for an arithmetic sequence or progression is T of n is equal to A, which is the first term, plus n minus 1 times D is the difference. N value is the position of the term, 1, 2, 3, 4, 5, etc. Okay, so let's look at example 11. So you have 4, 7, 10, 13, 16, 19, and so on. The A here is the value of your first term. It tells you that A is 4. The D is the difference. We can see that 4 plus 3 gives us 7. 7 plus 3 gives us 10. 10 plus 3 gives us 13, and so on. So when you're looking at an arithmetic progression or arithmetic sequence, what you need to do is first identify the value of the first term, which is A. Next, we need to identify the difference from one term to the next, or the distance, I call it, the difference from one term to the next, which gives us D, 3. So when we apply this formula, we simply plug in the value. So we can say for the next term, that will be 22, right? 19 plus 3 is going to give us 22. So when we apply this to the formula, we would say 4, which is the first value, plus 3 times 7 minus 1, which gives us 22. Okay. Any question? Okay, no question. So again, here is another example. We have -7, -1, 5, 11, 17, 23, and so on. So we see this, that your A is -7. And the D, you simply take one term and you subtract the previous term. So we can take term number 2, subtract 7, which gives us 6. -1 minus -7 gives us 6. And you can test that again with 5, subtract -1, which gives you 6, and so forth. So if we need to determine the 7th term, we simply take -7 plus 6 times 7 minus 1. Okay, let me rewrite that to make it better. So inside here you have 6. 6 times 6 gives you 36. 36 minus 7 gives you 29. Okay, and if you want to double check, you can use your calculator. So that's example 12. And again, you would also see that same in 13. But in this case, our distance, our difference is negative, right? You can see it's decreasing as we progress in the nth value. So your A starts at 30, so it's 30. Your difference, you take 25, subtract 30, you get -5. So for the 7th term, that will be 0. So 30 minus 5 times n minus 1. Okay, and if you plug in 7, you get a 0. Okay, so now let's use the formula, okay? Instead of doing this. So I'm gonna scoot this down a little bit. All right. So our formula that we're given, I'm gonna paste it on there so you can see. Let's take this. Put it here. Okay. So what is our A? Our A is 13, right? And what is the distance? So if we take our D is equal to 16 minus 13, which is 3. Or you can do 19 minus 16, you still get 3. It's a constant, right? The difference is going to be constant between one term to the next. So your T of n is A, which is 13, plus n minus 1. So if we need to find the 4th term after 19, which is 4 minus 1 times D times 3. Okay. So I should put T of 4 here so you can see. So our T of 4 would be, so inside here I have 3. 3 times 3 gives me 9, plus 13 gives me 22. Okay. Now to write the f of n, I did it like the first way. Okay. So you notice that there is the distance is going to give us the common ratio, which is 3. And then here 3 times n plus 10, so I'll highlight that, is going to give you the f of n or the t of n. Okay. So using our formula, we can still be able to come up with the value, and you can determine that for the 100 term, 1,000 term, 1,000,000 term, etc. with this sequence. So from here, what I did was I just put it when n is 1, right? F of n is 13, 3 times 1 plus 10. When n is 2, 3 times 2 plus 10, n is 3, 3 times 3 plus n. Okay. So I have 13, 16, 19. So I can see the n value appearing in each one here. So I can say it's 3 times n plus 10. Any question? Would that work with sequence that alternates? Alternates as in positive, negative sign, or are you talking about a certain type of sequence? There are only 3 types of sequence. You got the arithmetic progressions, the geometric progressions, and the quadratic progression. And right now we're covering arithmetic. Can you expand on alternate, Carlos? So we will go into the exponential one when we talk about the others, so you can see more closely on what they look like. Okay, maybe that will clear it up, but if you have an example, I like to see it. Okay. So in the earlier example, you see that's positive, negative sign, and you know that that's more on the exponential, right? And also times it by the negative. So we'll talk about the geometric and also the quadratic. Okay, so before we get into this, right, let's flip back and we recall that in the arithmetic sequence, each term equals the preceding term plus a constant. So when you move from one to the next, you simply looking at the difference in between. So we would add the previous value with a constant, okay, the previous term with a constant, and so forth, okay? So what I want you to do is to take a look at number 5, okay? And it says, which of the following options is an arithmetic sequence? You see part of the answer here already. So what we have is we have a constant, which is -9 that's added, right? So if we look at D real quick, right? So we can say T of 1, oops. We can say -9 plus 6 times n, which is 1, subtract 2, okay? So at this point, it's -1 right here, with 6, that's -6, minus 9, that's going to give you -15. That's T of 1. Now T of 2 is the same, -9 plus 6 times n minus 2, which is 0. So 6 times 0 equal -9. And just to test, t of 3 equals to -9 plus 6 times 3 minus 2, which is 1. That gives you -3. Okay? So you do see the progression across these values, right? I'll re-highlight this in a different color so you can kind of see. So we have -15, -9, -3. So the distance that you have is the 6. You add a 6 in between. So D is your answer. What's another one? There's another one. Anybody can find it? There are 2 that are arithmetic progression in the options. A. So let's check A. So A, if you 8 plus what gives you 16 plus 8? Right? 16 plus 8, does it give you 24? Yes. 24 plus 8 gives you 32. So yes, this is also arithmetic progression. Okay, somebody said B, I think Albert. Can B be an arithmetic progression? So if we start with n is 1, 1 plus 1 is 2, divided by 4, so you get 2, 4. And let me type it out. So let's say if we test this, it's 2, 4. And then what's the next one? If n is 2, 3, 3a. If n is 3, 4, 12. Okay, so what 3 is good? Can we take one and subtract the other and will it have the same distance? So 4, 12 subtract 3, 8. Does it give you a constant, and can you apply that same constant to the next 2? Or the previous 2, I should say. Okay, so B is no go. Okay. And we will talk about geometric and quadratic. So your A and D is the right answer for that. Okay. For number 5. Okay. Any question with number 5? So we understand the definition of arithmetic sequence and how to derive it. Okay, so for number 6, that's very easy. Just plug in the n value to provide the initial part of your arithmetic sequence. So you're given t of n is 5 times n minus 2. So you simply plug in t of 1. That's going to give you 5 minus 2, which is 3. T of 2. 5 times 2 minus 2 gives you 8. So we simply plug in the n value, right, for each of the term. When n is 3, t of 3, 15 minus 2 gives you 13. T of 4, term 4, 5 times 4, that's 20, minus 2, that gives you 18. So the initial, we have 3, 8, 13, 18, and so on. That's all we need for number 6. And the distance or the difference you see is 5, right, in between. And that's represented in the equation here. You see? Okay, any question? So eventually we're gonna look at recursion, right? That's coming up very soon. So this is why we're doing this, so you can see how you can go from one term to the next term. And we've been programming using some recursion in our C++ program. So okay. All right. So for number 7, we're gonna do the same thing. We're just gonna plug in the n value. So you're given t of n is -4 plus 8 times n minus 1. So you would take t of 1, then you plug in the 1. So -4 plus 8 times 1 minus 1 gives you -4. T of 2, -4 plus 8 times 2 minus 1 gives you 4. T of 3 equals -4 times 8 times 3 minus 1, or 4 plus 8 times 3 minus 1, that gives you 12. T of 4, same thing, -4 plus 8 times 4 minus 1, so you're plugging in all the n's here, which gives you 20. So our sequence is -4, 4, 12, 20, and we can see that the D, the difference, is 8. Okay? Any question? Let me double check something real quick. Okay. So those were the oh. What happened? Sorry, my dog. He's right underneath because they light fireworks, and so he just crawled under the table and he started yelping. Okay, so in the next part, we're going to talk about geometric sequence. So in geometric sequence, we simply multiply the previous term with a constant. So instead of adding like in the arithmetic sequence, we would multiply the previous term with a constant value, okay? Now in the geometric sequence, we can refer to that as geometric progression. And we would refer to the value that's being multiplied as the common ratio. Okay? And the formula for this is T of n is equal to A times R raised to the n minus 1. Okay. So for example, 14 in chapter 11, we have 2, 6, 18, 54, 126. Your A is the first term, which is 2. How do we determine R? We would take one term, the next term, term number 2, divided by the previous term. So if you take 6 divided by 2, you get a 3. 18 divided by 6, you get a 3. 54 divided by 18, you get a 3. So we can say that R is 3. So when you look at the geometric progression, you would see that it would multiply by a number to get to the next term value. Okay, in order to yield the next term, you would take the previous term and you multiply it by that common ratio value, which is R. So if we need to find the sixth term, we simply plug in 6 as the end there. So we start with A, which is our first term, 2 times 3 and raise it to the power of n minus 1. So n minus 1, so if we need to determine 6, 6 minus 1. So that would be, right, 2 times 3 to the power to the 5th power. Okay? Or you can simply take this value and multiply it by 3, which gives you 486. Any question? Okay, let's look at one more before we talk about quadratic. So here is our sequence. 1, -4, 16, -64, 256. And in this one, you see alternating sign, right? Positive, negative, and so forth. So we know that our A value, our first term is 1. And to get to the next term, we simply multiply it by -4, right? 1 times -4 gives you -4. -4 times -4 gives you 16. So we know that our R is -4. So when you look at geometric sequence, you first determine the first term value, then you determine the common ratio, the R, by taking the next term divided by the previous term. And you can test it throughout to make sure that it's the same. Okay? So if we need to determine the sixth term, we can simply take this and multiply it by -4, or if we applied the formula, we would take 1 times -4 and raise it to the power of 4 minus 1, which is -4 to the 3rd times 1. Okay? And that would yield -1024. Any question? So let's take a look at your assignment, number 8. It says select the option that represents a geometric sequence. You have A is 2 times 3 and raise it to n minus 1. B, 1, 2, 4, 8. Okay. C, 5 plus 2 and raise it to n minus 1. And then D is 211 over divided by 4 plus n minus 2. Okay, so which one is geometric, you think? Is A? A and B, question said. Carlos said A and B also. Anybody else? So if we look at B, right, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Yeah, you do have the common ratio applied there. For A, right, you would take 10 times 3 to the n minus 1, and you can test for each value. So you can plug in 1 for the first term, so you would get 0, so that will be 1. So the first term is 10, right? And then the second term, you would have 3 times 10, that's 30. And then the next term, you would get, what, 3, 2, 6, 60? Yeah, so you do have the difference there of 20 in the ratio, I mean, of 20. So yes, A and B is correct. So highlight that. Okay. The others are not, right? C would jump off the bat and it should tell you that's not. Okay. And then also D is not. Any question? Okay. So let's find the initial part of our geometric sequence. We're given T of n is equal to 64 times 1/2 and raise that to the n minus 1. So first you would plug in the 1. So T of 1 is going to be 64 times 1/2 and raise it to 1 minus 1, which is 0. Anytime that you have the 0 exponent, that's going to give you a 1. So 64 times 1 gives you 64. T of 2, 64 times 1/2, raise it to 2 minus 1, which is 1 here. So 64 times 1/2 gives you 32. T of 3, 64 times 1/2, and raise it to 3 minus 1. That's 2 here. So 64 times 1/2 to the second power, which is a 4th. So 64 divided by 4 gives you 16. So our initial, and you can keep on going, I just need to have at least 3. So your sequence starts at 64, then it goes to 32, 16, and so forth. So when you look at the difference here, right, what are we multiplying it by? So if you take 32 divided by 64, you would have a 1/2 common ratio. So your R is 1/2.
So Professor, how many numbers do you need in the quiz?
I just need at least 3. Not a big deal, right? So 3 we can start seeing, but 2 sometimes that can be vague. So yeah, 3 or more is okay. The point is for you guys knowing how to do this, right? Even though this is very easy, but we want to practice just to make sure everybody understands. Hey buddy, okay? Sorry. I have a 122 pounds German Shepherd Husky that thinks he's a little lap dog, so sorry. Okay. Any other questions? Okay, so for the number 10, we would do the same thing. We're given T of n is equal to 37 times 2n. And we need to find the initial part of our geometric sequence. So we have T of 1 is 37 times 2 times 1, which gives you 6, 7. T2 is 3, 7 times 2 times 2, which is 12, 7. And you don't have to reduce that. We can leave it like that so we can see the pattern. T3 is 3, 7 times 2 times 3, which gives us 18, 7. Okay. So if we take 12, 7 divided by 6, 7, then we can see the common ratio there. Any question? So make sure we understand the difference between arithmetic sequence and geometric sequence. Okay, arithmetic sequence is when we add the constant, where the geometric sequence is when we multiply the constant. So what's the common ratio? Rogelio asks. If you take 12, 7 divided by 6, 7, what do you get? Or you can do 18 over 7 divided by 12, 7. It's the same. Okay, so your R would be taking the next value divided by the previous value, because it would be a multiply as a constant across. You guys don't know how to divide fraction? So if you take 12, okay, if you take 12 divided by 7, 12 over 7 divided by 6 over 7, what do you have? You can cross it and then multiply it in reverse, divided by 6 over 7. So how do you solve this? Oops. I see some stuff in chat. Sorry, my Zoom, it keeps hiding it. Drop, switch, and flip. Christian, you want to explain drop, switch, and flip? Because I know the new method, the way they teach in school now is a little bit different than what I learned. I cross it, and then I, cross multiply and then reduce. Maybe that's what you meant. So, okay, reciprocate, multiply. Yeah, that's how I learned to multiply the reciprocal. Yes, that's exactly. Sheen, that's how I learned it too. So I take the 12 times the 7, the 6 times the 7, and then reduce it. Okay, drop the numerator, switch divide sign to the multiplication. Yeah, that's why we do. And flip the denominator. Yeah, and the same, that will be the same. So this would be your R. So when you approach geometric, what you want to do is we want to first to, you know, have the, if we want to apply the formula, we need to first determine our common ratio, and we also need to determine our first RA value. Yeah, let me double check that. 6, 2. So this and this gives you 2. You're right. It's actually, so it progressed 3, 2. So it should be 2 to the nth, not 2n. Okay. Yeah, because I think if we have it like this, it's not progressing geometrically. You're right. Thank you for catching that. So let's change this to that. Would that make a difference? Hold on, okay. 7 times 2 to the first. Oops. Is equal to 7 times 2. And then I have t of 2 is 7 times 2 to the second. That would give me 12, 7. Right. This is 6, 7. T of 3 is equal to 7 times 2 to the third, which gives me 8, 24, 24, 7. Yep. So this, yeah, so let's change that. Thank you for catching that. It's like 5 semesters that I've gone through this problem and nobody caught that. Okay, so if you change it to the exponent of n instead of 2 times n, you do see the progression as geometric. So let me fix that. So your S is going to be equal to 6, 7, 12, 7, 24, 7, and we can predict that it would be 48, 7, and so forth. So that will be 2, 2, 7 is the common ratio. So your R at this point is 2, 7. Let's eliminate that because it's not representing geometric. So that's fixed now. Okay, so what I did was I modified this. Make sure that for number 10, 2 raised to the power of n. And when you plug in the n value, you should have 6, 7, 12, 7, 24, 7, 48, 7, etc. So that will be, your R is 2, 7. Okay. Question. Let me see what you put in the chat. You're right. Sorry. Okay. So 12, 7 divided by 6. Yeah, 2. So Sheen was right in the first time that she mentioned that, right? So if we raise it to the n, then we get the r is 2. Okay. Any comment or feedback on this? Okay, so let's talk about quadratic, which is the next part. In quadratic, what you see is that you would have a sequence where you have the n term in the quadratic equation. So it would look like the quadratic equation like this, okay? So you have 2 of n is 2 times n squared plus b n plus c, okay? So in this example, example 16, you have 1, which is 1 times 1 to the first power, or 1 squared, I'm sorry, 1 squared, that's going to give you 1. 4, which is going to be n squared, 2 squared, that's 4. 3 squared, 4 squared, 5 squared, 6 squared, and so forth. Next will be 49, then 81, then 100. So your a of n is n squared. That would also be an example of quadratic. The next one is 6, 5, 28, 45, 66, and 91. So what you have is a of n is equal to 2 times n squared plus 3n plus 1. So when you're looking at a quadratic progression, you would see some form of, so this form would be represented in the quadratic, your quadratic formula itself. So you would see some value that's raised to the n squared, and then it would have some kind of arithmetic sequence after that. Okay. So now what we covered earlier is that arithmetic sequence is a linear function, and we would get the difference if the successive term is a constant. With the quadratic, what it is the difference between the successive term given the linear function and the second difference as a constant. So you would have a linear function and also the second level difference is a constant. And I'll explain how that's solved. So there are 2 levels of differences in the quadratic progression. With this, so let's take a look at example 18. So you have sequence 6, 15, 28, 45, 66, and 91. When you're looking at the difference between 6 and 15, you get a 9. 15 with 28, you get a 13. At 28 with 45, you get a 17. You notice that they're not the same, so it's not arithmetic, right? So you have the difference at the first level. Then you would take those and you would find the difference between each of the values. So 9 with 13, you get a 4. 13 with 17, you get a 4. So at the second level, it's a constant. And that what makes it a quadratic is that you have the first level of difference, and when from that level of difference you can obtain a constant difference from each of the terms in the differences. Okay, so in the quadratic function, you need to find the 2 level of differences. So you need to solve for a, b, and c based on the given formula. A of n is equal to 2 times n squared plus bn plus c. Okay, so the constant is the second level, and then we have a linear that's going to represent the difference. Okay. Okay, so from that, what we can do is first, we did like what we've been doing. If we plug in n is 1, then we would have, we would find that our equation would become a plus b plus c is equal to 6. So you simply plug in 1 for n, so a times 1 squared plus b times 1 plus c gives you abc is equal to 6. With n is 2, you have a times 2 squared plus b times 2 plus c gives you 4a plus 2b plus c gives you 15, is equal to 15. And then plug in n is 3, gives you a times 3 squared plus b times 3 plus c. And when we simplify this, we would have 9a plus 3b plus c is equal to 28. Okay, we're not done there. So what we did was we simply plug in the n value starting with 1. Then what we do next is we would take the first equation and we subtract the second equation, or the vice versa. The second equation subtract the first. So you would take this one and subtract this one. Okay. So here what I have is I have 4a plus 2b plus c is equal to 15. Subtract a plus b plus c is equal to 6. So the first approach is we plug in the n value to get at least 3, right? 3 is all we need. Then we take the second equation and we subtract the first, which gives you 3a plus b is equal to 9. Okay, that's the output from the subtraction. Okay, so let me label that. So this is the second step. And then for step 1, okay. So step 1, we plug in the n. Step 2, we find the difference by subtracting the second equation with the first. Okay. Then step 3, we would subtract the second equation from the third. So here we would do 9a plus 3b plus c, bring it down here, and we're going to subtract the second equation for the second step. Okay, so, or the third step. So we will find the next level of difference. So 9a plus 3b plus c, that came from plugging in the n. Subtract 4a plus 2b plus c, that's also coming from plugging in the n from here, from step 1. So when you find the difference, you would get 5a plus b equal to 13. Then in step 4, we would take this one and subtract this one. Okay. Subtract the output from the step 2. And the output from step 3. So we would have 5a plus b is equal to 13. That came from step 3. Subtract 3a plus b equal to 9. That came from step 2. And our output here, the last level of difference is 2a is equal to 4. At this point, we can solve for a now. Okay? So a is going to be equal to 4 divided by 2, which is 2. Then once we have the a, we would plug that in to the equation from step 3 to solve for b. Step 5. Use the a value to find b. Substitute a as 2, and then you would get, so b is going to be equal to 3. So when you plug that into this equation, for when a is 2, so 2 times 3 is going to give you 6, plus b is 9. Subtract from both sides, right? So b is going to be 3. So once you have the a and the b, your step 6 would be that you need to find c. So what we would do is we would plug that in to the next equation, one of the equations. A plus b plus c is equal to 6. So you have a is 2, b is 3. That gives you 5. And then you need to solve for c. So algebraically, we can solve for c. So here on the left, we have 2 plus 3 plus c is equal to 6. Subtract 5 from both sides, you get c is equal to 1. Okay. So once you have a, b, and c, then you plug it into the original equation where you would have a of n is equal to a times n squared, which is 2 times n squared, plus b times n, which is 3n plus 1. Okay. Any question? So let's look at your quadratic sequence. So right off the bat, this is for number 11. Sorry if I didn't label it there. So for 11, you have select the options to represent quadratic sequence. So we know that A, that looks like a quadratic formula. It is a quadratic formula. And D, okay. So you would have n to the second power minus 7n plus 8. Okay. Next, for number 12, we need to find the differences between the arithmetic sequence and the quadratic sequence. Here's my answer. For the arithmetic sequence, you have a linear function and the difference between successive term is a constant. In the quadratic sequence, the differences between the success term is a linear function and the second differences are constant. Let me check chat to see if you put anything else. And you can also find this in the notes. So we concluded there are two levels of differences in the quadratic, where in arithmetic you only have the constant as the difference. Any question? Okay, so let's solve for 13. So for 13, you have the sequence 4, 8, 11, 13, and 14. So we first would take 8, subtract 4, we would get a difference of 4. 11, subtract 8, we get a difference of 3. 13, subtract 1, we get a difference of 2. 14, subtract 13, we get a difference of 1. So as you can see at the difference, the first level of difference, you already started to see a progression there. And that's a linear progression, an arithmetic progression. We go from 4, 3, 2, 1, right? Negative 1 is the difference, or 1. So between 4 and 3, there's a 1, 3 and 2, it's a 1, and 2 and 1 is a 1. Okay? So when we use the formula, we would first start with, for n is 1, so we would try to solve for n is 1. Then we would plug in 4 is our a of 1 equal a times 1 squared, because n is 1, plus b times 1 plus c. And 4 came from the given quadratic sequence 4, the first number. Then next we would do, for n is 2, then we would plug in 8 is equal to a times 2 squared plus b times 2 plus c. And when we multiply this out, we should get 8 is equal to 4a plus 2b plus c. Everybody follow so far? Any question? Then we would do the same thing for n is 3. Then we would have 11 that came from our sequence, the third number, equal to a times 3 squared plus b times 3 plus c, which gives you 11 equal 9a plus 3b plus c. And then what we will do is we would find the difference by taking this equation, subtracting with this equation. Okay? Then we would take this equation, subtract this equation. Okay? And then the output from those, we would subtract them and solve for a. Then once we have a, we plug it in and we solve for b. Once we have a and b, we plug it in to this one and we solve for c. Okay, so here we go. Everybody follow so far how I got these? All right. So with the difference level 1, I simply take 4a plus 2b, that came from n is 2 here, plus c equal to 8, subtract a plus b plus c equal to 4. And when you line it up, you just subtract it straight. So 8 minus 4, right, c minus c, 2b minus b, 4a minus a. And that came from these two right here. When we plug in n is 1 and n is 2. So we would have 3a plus b is equal to 4. Then we repeat the same process by taking this equation, subtract this equation. So I take 9a plus 3b plus c equal 11, subtract 4a plus 2b plus c equal to 8. That gives me 5a plus b is equal to 3. Okay. After that, what we will do is we would take this one, subtract this one. So we would take the output from the second one, subtract the first one here, which gives us only a, and we can solve for a. So at the next level of difference, I would take 5a plus b equal to 3, subtract 3a plus b is equal to 4. These came from the previous output when we subtract those equations. Then we're left with 2a is equal to negative 1. So when we solve for a is equal to negative 1/2. After that, once we have a, we will plug it into one of the equations. So if we use 3a plus b is equal to 4, we can solve for b. And b is gonna be 11 too. So once we have a and b, we would plug it into the ABC equation. So a plus b plus c is equal to 4. Then we can solve for c. Once we have a, b, and c, we will plug it into the formula, which gives us the a of n. Okay? So when I have a and b, I take that and I plug it into this formula, or this equation. So I have negative 1/2 plus 11/2, that's a and b, plus c is equal to 4. So these two would give me 5. And then I simply subtract 5 from both sides. I get c is equal to negative 1. So once I have a, b, and c, I would use the formula from the top. A of n is equal to negative 1/2 times n squared plus 11/2 n minus 1. Yes, you can use that. I'll talk about Gauss shortly. And like Albert was asking is, can we do it another way? Yes, you can. But the whole point is to be able to put it into the AFN equation, right? And if we apply the formula that's given for quadratic progression, then this is how we would look at it, 2 levels of differences. Okay, so this is how we solve it algebraically. Okay, any question? So it is expected that you know how to be able to come up with your AFN function for quadratic progression. Okay, for quiz and test. Okay, very similar to the example there. So next we're going to talk about series. We're almost going to be done. We're just going to look at a couple of things and that will wrap up our session. So a lot of people mix up series and sequence. So far you already know what a sequence is. Series is a sum of the sequence. Okay? So when we're looking at the series, basically we add up all the values in the sequence. And in some cases, we would use partial sums. We would add up, let's say, the first 10 terms. Now in programming, this can be easily done by using loops, right? You can use a while or you can use a for loop. We just have to count it up to iterate through our container and then access the element at each of the index and have it sum up. So I call that the running sum. Okay, so now we can sum up certain set of the sequence, certain values in the sequence, like the beginning 10, like I said, that will be a partial sum. So in the arithmetic sum or arithmetic series, what you have is you can use Gauss trick. So the story is that he was one of the greatest mathematicians. However, when he was younger, right, his teacher would give him busy work, and he would have to add up all the numbers, right, like from 1 to 100. So he came up with an idea on how to do it quickly. So this is what they call Gauss trick, is to be able to calculate the arithmetic sum if you know the first and the last term. Okay, so far when we're plugging in TFN, we're trying to find like the 22nd term. We can add up the sum from the first term to the 22nd term or 10th term, etc. So the formula is that you would take the number of terms and you divide it by 2 times the first term plus the last term, and you would get the series output. Okay, so for example, if you are going to do from 1 to 100, you would take the number of terms divided by 2. Okay, so between 1 and 100, divided by 2, take 1 plus 100 and multiply by that. So use this formula. Number of term divided by 2 times first plus the last term. And that's called Gauss trick. Okay, so in this example, if we're doing 1 plus 100, we would take 100 divided by 2, which gives you 50. And then we would take the first term, which is 1 plus 100, which is 101 at this point. 101 times 50, which gives you 50, 50. Okay? So we can say that that will be n divided by 2 times n plus 1 in this series. Okay, so let's do one. So determine the arithmetic sum for the following sequence. And we're only going to do up to that 6th number. Negative 77, 60, negative 48, 36, negative 24, and 12, negative 12. So first, we have how many terms? 6 terms. So this is a partial sum. 6 divided by 2, the number of term is 6. 6 divided by 2 times the first term, which is negative 72, plus the last term, which is negative 12. Okay, that gives you negative 252. Okay, so first term plus the last term times the number of term divided by 2 using Gauss trick. Okay, yes, you can manually add everything up, right? But let's say that we need to determine the 20th term or the 100th term. So what you can do is you can find t of 100, right? Which is a value. You already have the a, the first term. And once you have the last term, you can calculate the length of it and then be able to apply Gauss trick. Question. So we need to know how to calculate arithmetic sum. Okay, so let's talk about geometric sum next. Any question on arithmetic series? And in geometric sums or geometric series, which is the sum of all the terms in the geometric sequence, we would see that a of a times r and then a times r squared, a times r to the third, and so forth, right? Because we're multiplying the common ratio. So we can conclude that, with some example there, but I'm running on the time, so I wanted to go directly to the formula so you can see. So you please take a look at the example when you get a chance. So the formula we should use for geometric series would be a, which is our first term, times 1 minus r to the n squared, to the n, divided by 1 minus r. And this is the formula we should use to determine the geometric series. And r is your common ratio. Okay, so when you're looking at the sequence, you can identify the first term. You can calculate the common ratio by taking the next term divided by the previous term. Then you would get the r. Once you have those two, you're able to determine the sum. Okay. Any question? So let's do the last one. We want to find the geometric sum of the first 4 term, and you can go higher. So we know that your r is if we take 30 divided by 10, we get 3. 90 divided by 30, we also get 3. So your common ratio is 3. The number of terms is going to be 4. So your K is 4. And your A is 10 because 10 is the first term value. Then to determine the sum of this geometric series, the sum of the geometric sequence or the geometric series, we would take 10, which is A, times 1 minus R to the n, which is 4 here, divided by 1 minus 3. Okay. So you would have -2 on the bottom here for 1 minus 3, and then 1 minus 3 to the 4th power times 10, right? Which gives you what? 800 divided by 2, which gives you 400. Okay. Any question? So after all of this, if we're given a sequence, we can first recognize what type of sequence that is or what type of progression that is. Based on that, we can identify or calculate the term value in that sequence. If we have the first term value and the last term value, we can also determine the arithmetic sum if it's an arithmetic progression. If it's geometric, we're able to also determine that using the formula. So we can calculate the sum definitely knowing the first term, right? The common ratio and the number of terms. And then we also worked on quadratic progression when we look at 2 level of differences and using algebraic expressions to solve that. Okay. Any question? Is okay, 1 minus 3 to the 4th power, it is not because its exponent is even. So if you 1 minus 3 is going to be -2 to the 4, right? I think the way I write it can be misleading, but so even if you take 3 to the 4th, -3 to the 4th power, what do you have? So -3 to the 2nd power is 9, right? And 9 times 9 is going to give you what? 81. So yeah, when you have an exponent that's even with the negative value, you're going to get a positive because negative times negative is going to give you positive. Does arithmetic sum work for quadratic sequences? At the first level of difference only, because the second level of difference in quadratic is a constant. Okay, that will only work at the linear level, and then you have to plus it with the constant, which is C. Other questions? Okay, so make sure we know how to solve this. And that would conclude, I think that's it. I don't have any more questions for you to answer. And do you have any other questions for me? If you want, you can stick around for a few minutes if you have further questions. Go ahead and type in your name in the chat so that way in case I need to get you for attendance. I usually just pull the participation list after this once we end the session. Okay. And I'm available for office hours in case you have any questions. Make sure that we use Mobile Learn to get some extra money. I know last year quite a few students did it and they actually didn't get as much as what they have this year. So, you know, try to see if you can use that. Okay, I know she told me she has 16 spots, so until that 16 spot close up, try to get it. Okay. Other questions? Okay, hope you have a wonderful night. I'll see you same spot, same time on Thursday. We'll do some C++ programming for sequence and series. Yay, have a good night, everybody. Take care. Bye. Good night, Albert. Do you have any questions? Something not clear? Okay, so I'm gonna sign off if you don't have any question. Have a good night, okay? Bye, Victor. Bye, Cameron.